going to talk about how to solve exponential and logarithmic equations. If you wanted to solve 5 to the x equals 10. Well, 5 to no power equals 10, nor can you get 5 and 10 to have the same base. So to solve for x, first we have to get it out of the exponent. So if on both sides, if I take logs, then this will equal log of 5x is equal to log of 10. That's what the second line says. Now the first line, the power of the 5 can come in front. That's the only reason we introduce any logs. And the right hand side is 1 because there's an unlisted 10 right there, and 10 to what power gives you 10? 1. This is 1. 1. Okay, log 5 is just some number. If you wanted to solve 3x equals 1, you would divide by 3. If for some reason you insisted on writing x times 3 instead of 3x, but it still equals 1, you still divide by 3. And if 3 is less friendly looking, like maybe it's log 5, you divide by log 5. Then you have x. Divide the other side by log 5. And there is your answer. You could have solved this using ln's, but this problem screamed to use logs because of the 10. Because log 10 was simply the number 1. Most times your answers, look at the very last line, most times your answers will involve 2 logs. Log of this divided by log of that. We kind of had that. Log 10 over log 5. Thing is log 10 is 1, just like it says there. So it was good to introduce logs because you got rid of, in the final answer, it got rid of one of the logs. It was simplified to a number, commonly known number. You have 10 to the negative x is equal to 2. Again, I would use logs. I would use logs. The other option, of course, is to use ln's. The power, this is the reason we took logs, the power can come in front. Okay, the power can come in front. Okay. But this number is 1. Log of 10 is 1. So negative x times 1 is negative x, and this equals log 2. Multiply log 2. Multiply both sides by negative 1, you get x is equal to negative log of 2. Now that is one answer, or you could realize that the negative is the same as negative 1, and then you can bring the power up. So you get log 2 to the negative 1, the log of, 2 to the negative 1 is a half, or 0.5. So either your answer is x equals negative log 2, or x equals log of a half. Either one. These are exact answers. If you work it out in your calculator, you're not going to have equal, you're going to have approximate. Because these numbers are irrational. An irrational number in decimal form goes on forever. Log 2 or negative log 2 is the exact answer. Log of a half or log of 0.5 is the exact answer. Okay, suppose you had e to the 7, e to the x is 5. E to what power gives you 5? Now since the base, remember this theorem, log base anything of that same thing to any power is the power. That is, no more logs. In particular, it even brings down the exponent. Okay, here it is. Okay, so if we take ln of both sides, let's look at the left side a little bit more closely. Remember, ln is shorthand for log base e. And we have this theorem down here that if these two match, then the answer is the exponent. So that's just x. So we're done. X equals ln of 5. That was the benefit of taking ln of both sides. Because the record, you could have taken log of both sides. The power comes down in front. So you have x times log e equals log 5. Divide by log e. Then you just get x. Divide by log e. This is not log times e, it's log e. Log 5 over log e. That's the same as ln of 5. That's the same as ln of 5. Calculate this. Calculate ln of 5. They should be the same. If not, there was a silly error done. This technique took a lot more than this, because we didn't use the right base. Of course, if the base is given, if the base given is not e or 10, here the base was e. In the previous problem, the base is 10, or the base is also 2. But one of the bases is 10. In fact, the base that has the power, sorry, that's what we're concerned about. I don't care about the 2. The base that has the exponent that you want to bring down is 10. In the last problem, the base that you wanted to bring the exponent down from was e. Use ln. When the base is 10, use log. When the base is something else, well then, you can either use log or ln. But you won't have one of the logs vanish. Like log 10 vanishes to 1. ln of e vanishes to 1. So what if you had e to the 2x minus 1 is equal to 100? Take ln of both sides. And you can, the left side is just 2x minus 1. And there's two ways of looking at it. You might like this better. The rule says, one of the rules says, you can bring the 2x minus 1 down. But ln of e is 1, because ln of e is log base e, that's ln of e. E to what power gives you back e? 1. This times 1 is just 2x minus 1. And that's what I wrote down right here. And this is equal to ln of 100. And that's the log of 100. Now we solve it. ln of 100 is a number. You can look it up in your calculator and get a good approximation for it. But nonetheless, it's a number. So we want to solve this equation. We're going to add 1 to both sides. So you have 2x equals. Now, in terms of notation, if you write ln of 100 plus 1, some people might think you mean ln of 101. But if you write the 1 in front, plus 1 plus ln of 100, you won't think that's ln of 101. And now if you have two x's and you want to just know x, you divide by 2. And there's the answer. X is equal to exactly 1 plus ln of 100 over 2. And we can check. I'll show you that that's exactly the right answer. Check. Well, what is 2x minus 1? I want to first find out what the power is. What is 2x minus 1? Well, x is 1 plus ln of 100 over 2. Well, the 2's cancel, so you have 1 plus ln of 100 minus 1. The 1's cancel, so you just have ln of 100. So the left side is e to the 2x plus 1, which is ln of 100. And the question is, does it equal the right side, which is 100? The answer is yes. You have a to the log base a. Note those are the same. Of 100, well then you get back 100. And the only difference is our a is e. Remember, ln is shorthand for log base e of 100. These are the same, so the answer equals this. This does equal 100. So we did check. You use your numerical answer that you get, say, from your calculator, it won't check. You'll get 99.93 for the left side. Because you're putting in an approximate number. And if by chance, when you plug in that number, you do get 100, well then what's happening is the calculation in your calculator is a little less than 100. If, say, your calculator only displays 15 digits, well, your calculator does some more. It does like 20 digits, and then it rounds off. So it's going to say that this is 100. It's going to round that off. But it's, okay, so coincidentally, you're putting in the wrong number, and out's coming the number you want. That's because the number you want, the exact answer, is really, really close to the number you're plugging in. So when the calculator rounds off, it'll still give you back the right, as if it's the right answer, 100. Okay, how about this one? So, suppose you have this. Suppose you have, okay, you have 2 to this 3x plus 1 is equal to 3 to the x minus 1. None of the bases that have exponents, there are 2 bases now that have variables in the exponents, 2 and 3. None of them are none of them are e, in which case I would take natural log of both sides, and none of the bases are 10. If there were 10, I would take log of both sides. There's a record if one of the bases was e, and the other one was 10, It's up to you whether you want to use log or ln. But in our case, in front of us, we don't have this. We don't have a base e nor a base 10. So I take log of both sides. And how do you take log of both sides? You write log in front of both sides. Simple as that. And then you bring down the exponent. 3x plus 1 times log 2 is equal to x minus 1 times log 3. Log 2 and log 3 are just numbers. I want to distribute on both sides of the equation the log 2 on the left side, and on the right side the log 3. And I'll get 3 log 2 times x plus log 2 plus log 2. On the right side, I'll get x times log 3, or log 3x's, minus log 3. Then I get all the logs on one side. And what I'm going to say is that this 3 goes up there, and now I have log 8. I have log 8x's, and I'm going to bring over log 3x's. So I'm going to have this number of log x's, of x's. And I bring the log 2 over. The right side already has a minus log 3, and now it has a minus log 2. Okay, let's come up to the top right. The number of x's we have is log 8 minus log 3, which becomes log 8/3. That's how many x's we have. And on the right side, I'm back in the bottom now. On the right side, if I factor out the minus sign, then I have minus log 3 plus log 2. But that's log 6. 3 times 2 is 6. So it's minus log 6. Minus log 6. And we divide by the number of x's we have, namely log 8/3. We divide by log 8/3. So x is exactly equal to negative log 6 divided by log of 8/3. That is the exact answer. Again, minus some silly error. Treat the logs as a regular number. Like back to this line. If you had 3x plus 1, not times log 2, but times 5. Well, you can think of the 5 as being in the front, and on the right side, you have x minus 1 times log 3. Well, if log 3 was 4, well, instead of x minus 1 times 4, you can say 4 times x minus 1. And then the next line was actually to distribute. That's what I did to get this line right here. I distributed. 15x plus 5 is 4x minus 4. Then I brought all the x's to the left and all the numbers to the right. Okay, that's what I did to get the last line here. This last line. And the line above, I brought over the x's and I brought the regular numbers to the right. And then you divide by the number of x's. I guess here you would have 11 x's is negative 9. So you divide by 11. That was equivalent of this equation up here. Well, we divided by log of 8/3. Very unusual number. But nonetheless, that is the number we use to divide by. Okay. Suppose you have this equation. You have x squared times 2 to the x minus 2 to the x equals 0. X squared 2 to the x minus 2 to the x equals 0. This is an exponential equation. Between here and here, I factor out what's coming. 2 to the x. 2 to the x times x squared gives you the first one, minus the 2 to the x times 1 gives you 2 to the x. 2 to the x times x squared is this, minus 2 to the x times 1 is that. That equals 0. Factor some more. We can't factor 2 to the x, but we can factor x squared minus 1. 1 is the same as 1 squared. So we have one thing squared, x, minus, must have a minus, minus something else squared, 1. So you write x and 1 in 2 brackets. 1 gets a minus, 1 gets a plus. Find the things that are being squared in here. The x and the 1. Okay, this equals 0. This cannot be factored anymore. We are multiplying 3 factors on the left. This times this equals 0. Well, either 2 to the x is 0, or x minus 1 is 0, or x plus 1 is 0. For example, the middle one, x minus 1 equals 0, x is 1. The right-hand one, this is 0 when x equals negative 1. The left one, it's never. No matter what x is, 2 to the x will always be a positive quantity. Which means this problem is now done. We have the solutions. Okay, when they say solve this equation, they mean for you to say, well, the unknown number is this or that. And the answer is it's 1 or negative 1. And we can solve it. 1 squared times 2 to the negative 1 minus 2 to the negative 1. Well, the big thing here is whether we plug in plus 1 or minus 1 in that bracket. Whether we plug in plus or minus 1. Plus 1 or minus 1. When we square it, we get 1. And 1 times 2 to the negative 1 is 2 to the negative 1. Well, if this piece is 2 to the negative 1, and you're taking away 2 to the negative 1, yes, indeed, you're getting 0. Suppose you had to solve this. 10 divided by 1 plus e to the negative x equal to 2. Remember, 2 is 2 over 1. First thing I would do here is I would take reciprocals of both sides. I would take the reciprocal of both sides. This needs to be a skill that you use. If two quantities are equal, if this equals that, then their reciprocals are equal. And if now I multiply by 10 on both sides, the 10 cancels out in the bottom left. That is, the left is just 1 plus e to the minus x, and the right-hand side is 5. Well, this must be 4. 1 plus 4 is 5. 1 plus this is 5. It's 4. Okay, now this is what we want to solve. This is what we want to solve. So, if we take ln of the left side, and there's the right side, and we take ln of it. Again, start catching on. Ln of e to anything equals that anything. This is just negative x. On the right side is ln of 4. Well, if two quantities are equal, then if we change their signs, they're still equal. I'll change that sign, and I'll change that sign. That is, I multiplied by negative 1. Or, two quantities are equal. If you change their signs, they're still equal. You can either leave that as an answer, or you can bring this up as negative 1, and you get x is equal to ln. 4 to the negative 1 is 1 over 4, which is 0.25. ln of 0.25. Okay, so either you can call it that, or you can say x equals negative ln of 4. And you can check it. Put it back in the original equation. Okay, how about you have this? Suppose you have e to the 4x plus 4e to the 2x minus 21 is 0. Now this here is a quadratic equation, because if you were to call that u, then that would be u squared. If that's u, well, when I square it, you multiply the powers. That e to the 4x. So, let's try to solve u squared plus 4u minus 21 equals 0. Since it's now 1u squared, we can try the game u followed by a number times u followed by a number. And the two numbers should multiply out to negative 21, but add up to 4. Fortunately, I don't know too many numbers that multiply out to negative 21 other than 7 and 3, or 7 and negative 3. And actually, they do add up to positive 4. They do add up to positive 4. So 7 is understood to be positive. So it's u plus 7 and u minus 3. Those two numbers, if you add them, I meant to put a plus here, if you add them, they add up to 4. And if you multiply them, they should multiply out to negative 21. Well, if this times that really does equal 0, then one of the this and the that has to be 0. Here u would be negative 7, and here u would be 3. But of course, if somebody gives you an equation that only has x's in it, and they say, can you please solve this equation for me? And you say, no problem. And you come back and remember, they give you an equation that has x's, like the top line. and you come back and you say u equals -7 or u equals 3, they're going to look at you rather strangely because they gave you a problem in x and you're saying where u is. So you need to back substitute. Instead of u, say e to the 2x, and that equals -7. Now, the problem here is if you remember the e to the x graph, any exponential graph, if you remember any exponential graph, it's always positive. This half has no solution. That is, e to the -2x will never be 7. Okay, what about this one? U is e to the 2x, and this equals 3. This one we can solve. Let's see, so we take ln of e to the 2x, and we take ln of the right side, which is 3. The answer on the left side is just the exponent. That equals ln of 3. So 2 times x equals ln of 3. Divide by 2. X is ln of 3 over 2. Ln of 3 over 2, that would be the final answer. Okay. In this case, there was only one answer. There was a good shot at it having 2 answers, but the second one could never happen. If it turned out that u was a positive number instead of like -7, we would have had 2 answers. Try to solve some logarithmic equations. You were told ln of x is equal to 100, or say 10. This is actually rather simple. First, you have to realize what you have. You have to know what you have. Ln is really log base e. But now, it's a routine procedure to solve for x. Convert back to exponential. E to the 10 equals x. E to the 10 is x. Problem solved. You have log x is equal to 3. Well, this is shorthand notation. Let's look at the longhand. Log means log base 10. So log base 10 of x equals 3. I can always tell you what that is. 10 cubed is that. 10 cubed is x. And 10 cubed is also 1,000. That is x cubed equals 1,000. Excuse me, x equals 1,000. I think I said x cubed equals 1,000. Suppose you have log of 4x minus 1 is equal to 2. Again, this is shorthand notation. Let's write out the longhand. For the record, if you're given this, I'm writing it down 2 times so it's in front of us. First, second time. But if you have this problem, you can just put the 10 down. And then you say, oh, 10 squared equals that. And 10 squared is 100. So 10 squared, 100, is equal to 4x minus 1. That must be 101. Because if you take away 100, excuse me, if you take away 1, then you do have 100. 4x is 101. And you want to add 1 to both sides, fine. But nonetheless, 4x is 101. Then we divide by 4, and we'll be done. We'll be done because you can't simplify 101 over 4. But now, we're not done. Again, this equation only makes sense if what you're taking the log of, namely 4x minus 1, is positive. Well, when 4x minus 1, when x is 101 over 4, is it positive? Well, the 4's cancel out, and you get 101 minus 1, or 100, which is positive. And just for the record, a quick check is, and we just did half the check, we found out that 4x minus 1 is 100, and does that equal 2? Sure. 10 squared is 2. Excuse me, is 100. 10 squared is 100. 4x minus 1 had to be 100. ln, that's 3x plus 4, is equal to 1. This really says log base e, that's 3x plus 4, is equal to 1. So e to the 1 equals all of that. But e to the 1 is e. And it equals all of that, which is 3x plus 4. So now we want to solve for x. Take away 4 from both sides. The left side gives you 3x. The right side is simply e minus 4. It's easier for that to be e, because if it was another number, you would have to do the subtraction. Like if it was 7, oh my, what's 7 minus 4? Here, e minus 4. And then you divide by 3. And you don't even have to consider if that, well, that's not true. So here is what x equals exactly. Now, if you remembered that ln of e is 1, you could have immediately said this is e, because ln of this is 1. You can say, oh, that's e. 3x plus 4 is e. And it took a couple of lines, but we said it pretty quickly. Suppose you were asked to solve this problem. Log base 2 of what's in the brackets equals 4. 2 squared equals what's in the bracket. 2 squared 4 equals what's in the brackets. It's a quadratic. Take away 4 from both sides. Factor. Use a quadratic formula. Okay, since it equals 0, and we have an understood 1x squared, when we factor it, if we see it, it'll be x followed by a number times x followed by another number. And the two numbers should multiply out to -6 and add up to 1, -1. And the two numbers will be -3 and +2. They add up to -1, but multiply out to 6. Excuse me, -6. And this is 0. So either x is 3 or possibly x is -2. But it can make what you're taking the log of equal to 0. we're taking the log of this. X squared minus x minus 2. Well, if x is 3, we get 3 squared minus 3 minus 2, which is 9 minus 3 minus 2, which is 6 minus 2, which is 4, which is greater than 0. So x equals 3 is okay. Now, we try the same thing when x is negative 2. You get negative 2 squared minus negative 2 minus 2. You get 4 plus 2 minus 2. You get 6 minus 2, which is also 4, which is greater than 0. Okay. Now, we didn't make a mistake here, but then again, we didn't need to do, there was no need to do a check in this problem, because what we solved already said that that's greater than 0. I mean, it equals 4. These are the numbers. These are the two numbers that make this equal 4. So, this is going to be 4 when x is 3 or negative 2. So we didn't have to verify that it was positive. It already stated that right here. It already stated that right there. In fact, when there's only one log, as long as you're not saying what you're taking the log of is equal to 0 or a negative number, you're okay. For example, if I told you log base 2 of 3x minus 1, oh, that's not true. It will always have an answer. Okay. If you have one log, you will always get the correct answer as long as you don't make a mistake. That is, you don't have to check it. In this problem that we're about to do, you will have to check the answer. So you have 2 log x, and that equals to log 2 plus log 3x minus 4. What you want to do in this case is, since it's only logs, you want to get one log on the left and you want to get it to equal one log on the right. If log A equals log B and A and B are positive, then A equals B. Okay, if this is negative, then this makes no sense. And if this is negative, this makes no sense. That is, log of negative 5 does not equal to log of negative 5. They're not equal. But if these two quantities are equal, if log A does equal log B, namely because A and B are positive, then A equals B. I want to write the left side as log of one thing, log of x squared, and the right side, since it's log of one thing plus log of another thing, I can write it as log of the product. Again, one log. Okay. If log of this equals log of that, then this must equal that. Okay, so the right side becomes 6x, take away 8. The left side is x squared. It's a quadratic equation. I'm going to bring everything to the left side That is, I'm going to get it set equal to 0. And when you bring a term over, like the understood plus 6x, it becomes minus 6x. When you bring over the minus 8, it becomes plus 8. Okay, x and x. Two numbers that multiply out to 8, that add up to negative 6. Well, that's negative 4 and negative 2. This is 0. So either this is 0 or that's 0. That is, either x is 4 or x is 2. Now, since we combined x's, we use some of those three rules. For example, now this is x squared. Well, this here, just looking here, you can allow x to be negative. But you know what? X couldn't be negative, because what you're taking log of must be positive. Okay, we used one of the rules. And so we have to check the very top line. When x is 4, what I'm taking the log of on the left side is x. If x is 4, then what I'm taking the log of, namely x, that is 4, is positive. Here, I'm taking log of 2. When x is 4, yep, 2 is positive. 2 is 2. When x is 4, 3 4 is 12. 12 take away 4, that's 8, that's positive. 4 stays. Not because it's positive, but rather because it made what we're taking the log of always positive. Let's check x is 2. Remember, I'm taking log of x. That is, I'm taking log of 2. That's okay, because 2 is positive. When x is 2, I'm taking log of 2. 2 is positive. That's okay. Here I'm taking log of 3x's, take away 4. Well, 3x is a 6, take away 4. I'm taking log of 2. That is good. You can take log of 2. So the answer is x is 4, x equals 2. But you must check. You have to check for x, and you also have to check for 3x minus 4. When you plug 4 in, 4 is positive. When you plug 4 in, you get 12 minus 4, which is 8, which is positive. 4 survives. 2, x is 2. Well, yeah, that's positive. And 3 2's minus 4 is 2. That's positive. So 2 gets to stay. 4 gets to stay. Log base 2 of 3 plus log base 2 of x this equals log base 2 of 5 plus log base 2 of x take away 2. There's only logs. See, if it also said plus 8, then we would do it differently. I would say bring all the logs to the left side. Bring the number to the right side. But since there's nothing but logs, I want to simplify the left side as one log, log base 2, and the same for the right side. On the left side, we are adding log. We have log of one thing plus log of another thing. Well, that's log of the product. Same thing on the right side. We have log of one thing plus log of another thing. Well, that's log of the product. If log of this equals log of that, there's a good chance that this equals that. 5x minus 10 is 3x. Well, I hope it's clear that must be 2x. 3x is equal to 5x minus 2x. 2x must be 10. You want to see that? You can bring the numbers to the right side, and while you're at it, bring the x's to the right side. I'm doing the same to both sides. I get 10 is equal to 2x. Like I said, say x is 5. That's the only possible answer. Now, we are taking x's of different things. We are taking, I meant to say log of different things. We're taking log of this, and log of that, and log of this, and log of that. And the question is, when x is 5, are those four quantities positive? Well, when x is 5, we'll have 3 in there. When x is 5, we'll be taking log of 5. When x is 5, we'll be taking log of 5. And when x is 5, we'll be taking log of 3. We'll always be taking logs of positive numbers, which is fine. And here's a real simple check. Log 3 plus log 5, yeah, that's log 5 plus log 3. Remember, we said that this is really 5 and x minus 2 is really 3. So log 3 plus log 5 equals log 5 plus log 3. So the answer stays, x equals 5. And notice that the base didn't come into play at all. Although you must verify that they are the same base. If they're not the same base, maybe you could use a change of base formula so then they will be. Suppose you have log of x plus log of x minus 1, and this is log 4x. Log 4x. So the right hand side is log 4x. And the left hand side is log of this plus log of that is log of this times that. Log of this mess equals log of that mess. So x times x minus 1 equals 4x. That's what we want to solve. If there is going to be an answer, it's going to come from here. So you have x squared minus x is equal to 4x. I'll take away 3 x's, and you get x squared minus 4x. Okay, so let's see our little mistake. Okay, so of course to get it equal to 0, we should be taking away 4x's. We want to get the right side equal to 0, so we take away 4x's. And then we'll have x squared minus 5x. Well, if you factor that, you get x times x minus 5 equals 0. So either x is 0 or x minus 5 is 0. But x minus 5 is 0 means x is 5. So those are your two possible answers. X is 0, x is 5. The first thing I might say is 4 times 0 is 0. Can't allow that. Or if I looked at the first one, I would have said, oh, I'm taking log of 0, I can't. Or I would have said, I'm taking log of negative 1, and I can't. So x equals 0 is history. It's not there. What about 5? Well, if x is 5, then this will be 5, and this will be 4, and this will be 4 times 5, or 20. So the right-hand side says log of 20, and the left-hand side says log of 5 plus log of 4. But yeah, that is log of 20. So there's your check. Log of 5, because x is 5, plus log of 4, 5 minus 1 is 4. Well, that's log of 5 times 4, that's log of 20. That's exactly what the right-hand side says. Your check shouldn't be brutal. You don't need to write down as much as you think you do to do a check. Log x plus log x minus 3 equals 1. This is what I was talking about earlier. If you have logs and you have just a plain old number, you need to isolate the logs on one side with the number on the other side. This has already been done for us. Then you write the side that has logs as one single log. Log of A plus the log of B is log of AB. And this is 1. So what must be this quantity? Okay, so if it's 1, I shouldn't write 10. What must that quantity be? Answer is 10. Remember, log is shorthand for 10. And 10 to the 1, which is 10, is supposed to equal that. The x times x minus 3 must equal 10. And this is a problem where I don't think you should FOIL out and set equal is 0. I think you should realize that whatever this number is, this one is 3 less. So let's get 10. Well, yeah, if you looked at 10 times 3 less, that's too much. If you looked at 9 times 3 less, that's too much. That's not 10. If you looked at 8 times 3 less, that's 40. If you looked at 7 times 3 less, that's 28. If you looked at 6 times 3 less, that's 18. If you looked at 5 times 3 less, what do you know? That's 10. Okay, so remember, x was the larger number. So you can have x equals 5. But you know what? In addition to, and this came from 5 times 3 less equals 10. But you know what? If x is equal to negative 3, if x times 3 less is 2. If x is negative, okay, now I see. If x is negative 2, well then 3 less will be negative 5, and that also gives you 10. That is, you don't just have to have 5 times 2. You can also have negative 2 times negative 5. And if that's x, that's 3 less. So the answers are x can be 5 and x can be negative 2. Those are the possible answers. Those are the possible answers. We have to verify that they don't make what we're taking log of negative. And we are taking log of x and x minus 3. Well, let's try 5. If x is 5, then this would be log of 5, which is allowed. And this would be 2. And log 5 plus log 2 is log 10. But you know what? That does equal 1. And what we're taking log of, most importantly, was positive. 5 and 2. So 5 stays. Negative 2 will not. because if x is negative 2, then I'm taking log of a negative number. It's enough just to find one case where it'll make x negative or 0. And for the record over here, negative 2 minus 3 is negative 5. I'll be taking log of negative number. But you know what? The reason it's giving you that answer is because if you made the mistake and you multiplied negative 2 times negative 5, you will be taking the log of 10. So the left side is the log of 10, but that does equal 1. Okay, when we went to this line here, it wasn't exactly like the line above. The second line allows for x and x minus 3 to be negative. Because if both of these quantities are negative, when you multiply them, you get a positive answer. It also allows for both of those quantities to be positive. When you multiply two positives, you get a positive. They can't be different signs. Multiply different signs, you get negative. None of them can be 0. Because if either or both of them were 0, the product wouldn't be positive. Okay. But the line above said, oh no, x and x minus 3 must be positive. The second line says they can both be negative. That's why you get sometimes an erroneous answer. And if I'm not mistaken, negative 2 did not work. So the only answer is x equals 5. We'd like to just spend another moment on solving those types of quadratic equations. You have x times x minus 3. Or how about x minus 2? And you're told this is 80. We want two numbers to multiply out to 80. Here's one number, the other number is 2 less. You can try 10 times 2 less. Ooh, there it is, done. X is 10. Okay, that is, you can use 10 and 8. And x is the larger one. X is always larger than x minus 2. Because on a number line, if here is x, x minus 2 will be 2 to the left. Given any two numbers on a number line, the one to the right is larger than the one to the left. Okay. You can also have negative 10 times negative 8. But that's the larger number. That's x. That's 2 less. That is, x can be 10 or x can be negative 8. Those are your answers. If that's x, then negative 8 can also be x. The other number with a negative sign. X can be negative 8. If you had x times x plus 3 is 180. So you have the number times 3 more, and that's to give you 180. Well, try 10. If you have 10 and you multiply by 3 more, you get 130. Well, that wasn't enough. Now you could go to 11, or you can say I need to go a bit more. This is 154. And if you try 15 times 3 more, well, actually that's 270, so it actually was somewhere in there. How about we try the very next one, 12. 12 times 3 more, well, I don't know what I was thinking, that's 180. So that's x. X can be 12, and it can be negative that number. because there are two other numbers that differ by 3 to multiply to 180, like negative 15 and 3 more, negative 12. This is 3 more. Negative 15 plus 3 should be able to do that. So that's x. That's 3 more than x, and it's 180. So x can also be 15. Once you find 1x, that other number, change the sign, and you'll have the other answer. The alternative is to multiply this out. You get x squared plus 3x, bring the 180 over, minus 180 equals 0. Now you have to factor here. I'm just doing elementary school multiplication. So maybe that would be an easier method. Problem is, if they're not integer solutions, you won't get it. You'll never think of multiplying 1 plus square root of 3 times 3 more than that number to get 180. Okay, suppose you have log base 2 of x is equal to 2. So log base 2 of something is equal to 2. What goes in there? 4. 4 goes in there. 2 squared is 4. 2 squared, 4 is that. That is what's in the brackets, log base 2 of x is equal to 4. I couldn't care less what's in the bracket has its own logs. It doesn't matter. It doesn't matter what's in there. What matters is you know the locations. It's log base this of that equals this number. 2 squared 4 equals what's in there. What's in there is equal to 2 squared or 4. Well, what's x? 2 to the 4th. Oh, that's x. 2 to the 4th is x. And 2 to the 4th happens to be 16. It's 4 times 4, 16. Okay, so log base 2 of 16, that equals 2. I just rewrote the initial problem, except instead of x, I put our answer, 16. Okay, that completes this section on log and exponential equations, and it also finishes the pre-calculus video. I hope you enjoyed it. Thank you, and good luck with your studies.